Okay. Yeah, so I already sort of introduced myself a little bit, and I should add to that that like the goal of the research that I and my colleagues here in Atlanta are doing is partially to get a sort of fundamental understanding of how science operates from the team level to the system level as a whole, but also to try and figure out how we can design interventions. So if we have some optimal distribution of outputs in mind, what sort of interventions can we make to get us there?
Mm.
So, my goal today is like sort of to build on the previous journal clubs. And I'm going to present two mostly descriptive papers that I think do a really good job of sort of creating a framework for us to build on with some more empirical work in the future. So I think Mark shared both of these. They're two sister papers by Henry Sauerman and Chiara Franzoni. First one's in research policy, which is more in the organizational side of things. And then the second one in PNAS is looking at user contribution data and trying to understand what do patterns of user contribution actually mean for these projects. Okay, so the first paper, the task here is basically to try and present a conceptual framework to support future analyses into what's sort of alternately referred to as crowd science or citizen science, and sometimes open source is looped in there too, in the same terms that we talk about academic science in. And so the first problem they have is, how do we differentiate this sort of really hazily, messily defined group of communities from what we're more comfortable talking about? And they're going to propose two basic dimensions along which we can distinguish crowd science from other forms of knowledge production. And they're mostly going to distinguish this relative to what's called Mertonian science. And if you're not a sociologist, Mertonian science doesn't mean anything to you. So what he's talking about really is the sort of environments that most of us either work in during our PhDs, or if you're still in academia, are working in currently. And Merton sort of argued that there's four basic norms that characterize this type of science. First is communism, that we share our final results in papers and at conferences. Second is universalism, that the validity of my claims is independent of how famous or not famous I am, and all sorts of other elements of social status. Third is disinterestedness, that institutions are generally acting for the common scientific enterprise rather than any individual personal gain. And then organized skepticism, which is the sort of peer review that we all love so much. In addition to
reviewer too, right?
Yeah. Merton doesn't describe reviewer two in detail. I think it's implicit in his work. He published lots of books, so he didn't have to deal with it so much. And then, so probably the most important part of it is that above all else, science really rewards priority and originality. If you're the first person to produce really great breakthrough work, you get the biggest rewards. You get those mostly by being recognized by your peers through citations, and then you sort of accrue resources because of that. Better graduate students, more money. So we are going to characterize these different forms of knowledge production along two axes. And these are both degrees of openness. So the horizontal axis is openness and the disclosure of intermediate inputs, and I'll describe what that means in a second. And the vertical axis is openness and project participation. So when they say intermediate inputs, they're talking about things like data sets or protocols for performing experiments. Now, because of this incentive for priority, we don't usually share intermediate inputs in academic science. If I get like a really promising result, I don't rush to Twitter to go post it because I could get scooped and lose that priority. And then participation in sort of Mertonian or academic science is exclusive. You either have to apply, or you have to apply to PhD programs to a lab. You have to be asked to collaborate, and so it's not open entry. In contrast to this, Sauerman and Franzoni argue that crowd science is basically the polar opposite of this. That first, participation is open. In other words, nobody's really excluded from entering the project. The only requirement is that you sign up. And so that's not costless, but it's certainly a very low bar to entry. It's really based on self-selection rather than assortative selection or anything else. And then the intermediate inputs are disclosed and shared not only within the communities, which can be quite large, but also beyond it. And so they argue that these two things are really a really simple way of differentiating it. I think they do a pretty good job here. And just this really simple model is already suggesting a few things to us. So if we want to shift an organization like Jogel to the left on this chart, we can institute rewards for priority. We can make rewards for particular pieces of work exclusive rather than inclusive. And then we can shift down by adding an application and approval process. And we can already see there's, for instance, the funding within Jogel is already shifting down a little bit some of these projects. So we might have heterogeneity even within the Open COVID project that we can exploit for analysis. So that's the first problem, is probably the least interesting one, is just trying to explain what is crowd science and how is this different from the other forms of knowledge production that we're used to. And as they sort of walk us through this, they're doing it with 3 case studies, one of Foldit and Polymath and one called Galaxy Zoo. So it's clear that these are different than the sort of work that we do every day in the lab, but there's still a lot of heterogeneity within them. And so the second task they have is to try and give us a way to understand and explain the differences between projects in a way that that supports analysis. And they're going to do it with another 2 dimensions, because 2 dimensions are really easy to show on charts. And they're collapsing down really a lot of detail here. But it's still pretty parsimonious. I think it's reasonable. So the first, they're looking at 2 things: the level of skill that you need to meaningfully contribute to a project, and then the nature of the tasks that you're performing within a project. And they break down the task level into 2 subcomponents. The first is the task complexity, which you can think of as the degree of interdependency between any pair of subtasks within the larger task. And then the task structure, which is the degree to which we basically understand what we need to do. So the degree to which we know what subtasks need to be done, what is a appropriate completion of a subtask look like, right? What are the performance criteria? And then what's the general problem space? This is really closely related to things like the ability to plan and to organizational features of organizational structure, like standardization, which is the degree to which we can specify exactly what we need to do in advance, and formalization, which is the degree to which this is sort of formally encoded in writing. So these 2, complexity and structure, are often correlated, and they're totally bunched together in the chart I'm about to show you, but they're formally distinct, and they're not necessarily, one doesn't necessarily imply the other. The correlation is usually highly complex tasks will be ill-structured. This is because the more complex it is, the more difficult it is to understand the relationships between all of those subtasks. But we can think of plenty of cases where that's absolutely not true. So like operating a nuclear power plant, for instance, is a very complex task, but it's also very well structured. So we pretty much understand what we need to do.
And is there such a task as coming up with tasks, which is basically being the last author of the paper, right? Which
yes.
Is,
yes, you can go. I mean, you can go really deep into the task. Yeah. So what they're looking at here is trying to look independent of the content of the task and just look at features of it. But there are really important differences. One, in like even at the field level, and the type of task structures and complexities that you're likely to see. So biology tends to be much less well defined than things like high energy physics or computer science. And and then at the level of the individual task, when we move into executing a project, we are generally going to become a little bit more, like when we move from research to development, we become a little bit better structured, regardless of complexity. So there's definitely differences that they're not pulling out. And so in addition to the task stuff, they also include the level or the extent of skills that are required to sort of meaningfully contribute. And there's a implicit assumption here about performance criteria, right? Because meaningful contribution is relative to some performance criteria. They don't pull it out here. We'll talk about later how annoying that's going to be to try and measure with Joggle. But they're basically looking from common human skills, like I can recognize whether something's a hot dog or a banana in a photo. So the kind of stuff that you do in catchphrases on web forms all the time, to more specialized and then domain-specific skills. So a domain-specific skill might be developing the classification algorithm that all of these CAPTCHA users are feeding.
Bastian asks if skills and knowledge are used interchangeably here.
I think for their purposes, they say yeah. I think for this situation, yeah. You can decompose all of this stuff. And if you talk to the people on expertise, they'd be screaming on the inside right now. But yeah, they're being used in the same term. I'd say that generally in my work, I usually break out skills, knowledge, and norms from each other. So like anything related to the skill and relating to other people or understanding how to work within an environment, I usually break out into norms. But for this situation, it's all together. I can't see the comments, by the way. So Mark, if you feel like reading them out,
yeah, I'll do that.
That's awesome. Or just jump on the mic. It's I don't mind. Okay. So they've got a bunch of these. They have a supplemental section full of different projects, and they start to loosely map these onto these two dimensions. So we're moving from less complex and better structured on the left to more complex, more interdependent subtasks and less well-structured on the right. And then as we move upward on the vertical axis, we're increasing the degree of skills we need. And so in the bottom left corner, we have this sort of image, like a human image recognition task that we talked about earlier. And then in the top right, we have this example, polymath, which is started by a Fields medalist named Timothy Gower, and where they're sort of collectively solving quite difficult mathematical problems. And you'll notice that most of the examples are in the bottom left corner, and particularly towards the well-structured task. I think there's a lot of selection bias there, in not in their sample, but in what people are willing to sort of put on these platforms. It's quite difficult to organize a bunch of people around an ill-structured task. So if I can break it down into really simple subtasks, it's going to be a lot more easy and a lot more likely to be shared on these sort of platforms. I think most Joggle projects are probably in the underpopulated side of this. Like there isn't a whole lot of like image recognition or going out and spotting what are all the types of birds in my neighborhood, which is inconvenient for us, but gives us some opportunities that, for analysis. And then there's a couple things that they kind of mention, but mostly don't, that are really important here. The first is that the more we can decompose the subtasks, the more we can increase division of labor. And most of the time when we can increase division of labor, we can really increase productivity, often at the expense of other things like creativity and novelty. we can also, we don't all need to sort of meet in the same room at the same time. We can communicate asynchronously. We can leave comments or issues on a GitHub repo. We don't need to all get in a Slack every day or get in a Skype every day. And we can use more impersonal modes of coordination. Leo, are you trying to say something?
Yeah, just Bastian was asking a question, which I think is very interesting, and I have my opinion, but where do you fit Wikipedia onto your graph?
And
would you even consider Wikipedia a crowd-science project?
So, I mean, let's go back here. I think it's tough. It's like Wikipedia, from what I understand, is semi-open, right? So most people can contribute, but there are some limitations in what you're allowed to edit.
Well, I mean,
So
my understanding, just so that we're clear, and it's related to a question, who can come up with a task? Here you're talking about cases where someone has come up with tasks, and then you're deciding who gets to solve them, right?
Yeah.
There's nothing here where people come up with tasks themselves, which is the case for Wikipedia or iGEM or anything. Here we're talking about outsourcing and intelligent outsourcing.
Well, I would say,
yeah.
But like Wikipedia has like an overarching task, which is make a big encyclopedia, and you have interdependent subtasks, which are kind of well-structured.
So that would be Wikimedia almost. Okay.
No, but also Wikipedia itself. I mean, you have one very clear task, which is make the world's biggest, most complete encyclopedia.
Yeah. I was going to say, actually, for me, Wikipedia is pretty well structured in terms of tasks, right? Because each subtask it's always the same subtask. It's share the little bit of knowledge you have onto that Wikipedia page, right?
The benefit of
the exact same thing.
The big difference between Wikipedia and most of science is that in much of science, the knowledge base is not known in advance, or you have limited knowledge. Where in Wikipedia, the knowledge base is entirely known. There's nothing really novel on Wikipedia. So I think that's the big thing. But we could see, depending on the type of knowledge they're contributing, we could see them anywhere up and down the vertical axis. I think you're right that it's generally going to be well structured, though.
I like this
point. That was my, basically I was going to say, like, I think Wikipedia is a sort of a uniform distribution on the Y and pretty skewed towards the left on the X-axis.
Yeah, but Mark also makes a good point that not only are all of these tasks, particularly in the bottom left, these are specified very narrowly, but it's in all of these cases, there's a very experienced senior scientist that's has either specified the problem space and specified the questions and the methods to start with. And so I think it's unlike Wikipedia in that sense, that in Wikipedia, the leaders have expertise in the platform, but not in the content. Where here, the leaders generally are content experts.
I would say the subtasks also range from well-defined and independent to very ill-defined and interdependent, depending on where you try to contribute.
It depends. I mean, I think a lot of what seems more ill-structured is the degree of skill that you need to efficiently search. So if I'm not very skilled, like if I try to write something about most of the stuff that you guys do, my search costs are extremely high. It's going to be really hard for me to find and then understand the appropriate content to include. Where if you're much more skilled, then the costs are lower. But that doesn't necessarily mean that that doesn't necessarily say anything about the task page without necessarily being dependent on somebody editing another portion of that page. Except for in the hyperlinks, I think it's mostly independent.
Well, I would say they're interdependent in the case that like people come chronologically after each other and edit each other's articles. So they are dependent on what other people have provided before, because you're using their outputs as inputs for your task. And it can be very well structured if you say you just fix typos, which probably is on the bottom left of the scale, where it's like very common skills and it's very well structured, all the way to you start a new article about a topic where there's nothing. So you actually have a very ill-defined structure, and you probably depend a lot on other people giving input.
Yeah, though it's important to note that we can take if we have a well-structured task, we have a lot more flexibility in that sort of workflow that we use. Where if we have an ill-structured task, it's really difficult to do that. We're much more limited on what we can do. We have to do things much more in series or in team sort of coordination modes. And as we move to more independent, well-structured tasks, we can organize the workflow in a lot of different ways. I see what you're saying on the input side, though. I think that's basically right. Yeah. Okay, so I'll move. Okay, yeah. So most Juggle projects. Yeah, coordination and synchronous communication, and then probably most interesting for Pedro, as we're moving up as we increase in the level of skill that we require, our potential labor supply is decreasing. So the probability that we can find an appropriate person to match to a project that requires a high level of skills is going to be quite low. So that's where a recommender system and recruiting is really important. Where, lower down the hierarchy, we're less focused on matching on skill and are probably more focused on matching on preferences. Higher up, we really need to understand exactly what people are bringing to the table.
That's very interesting.
I think that's, so I mean, these are both pretty simple papers. Like that's basically the core of the first paper, those two problems. And then they're going to move to the second paper and start to apply that sort of simple conceptual framework. And they're going to try to understand, well, they're going to start with all of these sort of conjectures about the benefit of crowd science that are discussed a lot of places but aren't empirically tested anywhere, which is always fun in the social sciences. And they're going to give some really simple tests for one of them. The basic questions here: how do the ways that users contribute matter for projects? Right. So we've got a lot of different benefits of crowd science, which they pull out of some of the existing literature. So the first one, which is one they'll focus on, is that because contributors to crowd science projects are largely motivated by non-pecuniary factors. That is, they work because they think it's socially important, or they get some value from working with people and building friendships, or they just really like performing the tasks instead of working for monetary compensation. And basically, crowd science projects should be able to use the same quantity of labor inputs at much lower costs, right? Because we're not paying people's wages. So they're going to test this, or they're not going to test this. They're going to like give a cool counterfactual and basically describe how much these projects should be saving. And then we have some other benefits of crowd science that they bring up, which are not really discussed for the rest of the paper. Some people argue that when you can recruit a large number of people, you can work in parallel. If you have a well-structured task, you can work faster. That seems reasonable. There's some stuff about being able to access relatively rare skills or knowledge, particularly the type of skills that aren't common in academic science, by sort of broadcasting out, right? So this is sort of a network effect. The more people we have, the broader we can expand our search for new contributors, and the more likely we might be to find people with the kind of weird skills and characteristics that we need. for projects that require creativity, people argue that you can benefit from having a rich and diverse knowledge base from a lot of contributors. In almost all of the crowd science projects that they bring up, creativity is not important. In very few of them. I'd say like Foldit and some of the protein folding ones where people are kind of generating their own recipes for how to, for how to play with the folding algorithms. You're moving towards needs for creativity, but in most of the stuff with the greatest numbers, which are the classification tasks, not important at all. And then there's some argument that, okay, we lose people pretty quickly, people move in and out, but if we can spread them across time and geographic space, we can increase our coverage. So if I'm doing like an ecological study, if I want to understand all the species of birds in everybody's neighborhoods, this is a real benefit. And then finally is the sort of catch-all that everybody puts in their papers so that NSF will fund them, which is that involving the public might benefit science education and advocacy. I'd argue that this is a very high cost way to do that, but that's just me. So they're going to look at user contribution patterns across the largest sort of crowd science platform of its type, which is called Zooniverse.org. And they're looking at 7 crowd science projects. They don't say anything about sampling, but I don't think it's a huge problem here. And they're looking at all of the user activity logs for the first 180 days. So there's a total of about a little bit over 100,000 total users. And they've got 12 million daily observations. And these observations are basically how long did they spend working in the platform and how many subtasks did they complete, which for reasons I'll explain later, they can classify really easily. So there's some similarities to Joggle that are really helpful. So first, it's a similar sort of shared platform infrastructure. There's a lot of heterogeneity in the type of fields that are included and the kind of tasks that people need to do. Much less heterogeneity here than in Joggle, but still. And then these are also primarily led by the sort of people who would be PIs in academic science.
So typically a project is like, I want to observe that particular region of the sky, and I believe there should be that density of whatever types of objects, and then that's a project, and they need to just classify whether it's a particular, maybe can you, like, because it's 7 different projects, can you just explain what they're,
yeah.
Consistent?
Yeah, so I think it's a slightly larger scale than that maybe. So I think like the Planet Hunters project, they're not necessarily, I think maybe they specify down to that level, but the project captures a much broader range of sort of searches. So the tasks will be relatively constrained. The tasks will be pretty similar to each other, but instead of looking at one particular part of the sky, they might be conducting a whole range of activities looking for new planets. So I think it's probably broader than most of a project here is broader in scope than most of the projects in Open COVID. And also most of these are orders of magnitude larger. Actually, the smallest one they use here has a little bit under 3,200 users, which is roughly equivalent to the size of Open COVID as a whole. So we're looking at pretty big differences in scale. There's problem with scale. The big problem is that the tasks are much better specified, and they say that there's heterogeneity in the tasks. There is, but there's heterogeneity within the sort of well-structuredness. And so from an organizational perspective, it's a little bit different to what we're looking at. Talked about that first sort of that first conjecture about sort of motivations for participation, that users are trading their labor in exchange for these non-pecuniary rewards. the authors here are saying, okay, we have a few counterfactuals that we can use to estimate how much these projects would have had to pay to get somebody to perform that work. And it's important to note that they're not saying how much they would have had to pay that exact user, because that labor price is 0. And they're also not saying how much does it cost us to recruit this person or support that work, because that cost is could be quite a bit larger than 0, right? That's like all of the operating costs of the platform, basically.
So Dule asks, how does that compare to Amazon Mechanical Turk?
Oh, just you wait. Yeah, so one of the counterfactuals they use for the Mechanical Turk pays on a piece rate. Usually, I don't know of anything that doesn't pay on a piece rate. So it'll be like you'll get a couple cents or a couple dollars for each classification. Or if you're doing social science projects, sometimes it'll be a lump sum. So they're actually going to use the cost of classifications from Amazon Mechanical Turk. They're going to use that piece rate to estimate the cost of replacing that labor. So that's a great question. Yeah, I kind of already got into it, but the first thing they're going to measure is the hours worked, and they can get a good measurement of this because people basically do almost all of the work on the platform, like within their interface. Yeah, so we're already getting annoying for Joggle. And then, and so they're going to use a counterfactual from a typical hourly wage of an undergraduate research assistant, which I think is a pretty good one. And then for they also have the number of classifications because they can very clearly define what a task is. And they're going to use they can use that to get the piece rate. So the piece rate is what you used to, like in really old factories, like what this kind of stuff that Adam Smith was studying, you get paid a piece rate. So, or in Foxconn today, you get paid for the number of iPhones you make. And that's the sort of wage structure they're going to test with the second measurement. And the piece rate they're using is for similar microtasks from Amazon Mechanical Turk. So just like you brought up. And we can see there's some variation in which one is greater. This probably has to do with the size of the tasks. So where the cost of classifications is lower and the undergraduate hourly rate is higher, that's probably because, or sorry, the cost at the hourly rate is higher. It's probably because the tasks are larger. It just takes more work to do. They don't really test that explicitly. And so we can see that the contributions here are pretty substantial, right? So in the $20K to $700,000 range. There's a couple limitations here. I really like these counterfactuals, but first, they've got really great data to do this with because Henry's a very smart person. And so they have really good measures of, they have a clearly defined minimum unit of output. And they're pretty sure that they don't have any measurement error in the hours worked. So because people need to be on the platform to perform these tasks, you can't sort of take it home with you, so to speak. They can be pretty confident they're actually measuring everything they think they're measuring. And then it's difficult to expand this to less well-structured tasks because of that, and difficult to expand it to Joggle because people do work all over the place.
No, but I think there's a good, that's something I wanted to look at in the context of the iGEM wikis, because for the iGEM wikis, we can now, for example, through the wiki contribution, we can have an estimate of the number of days the person has spent working in the team on the project. So you can convert that into some kind of total amount of work for a given team.
Yeah.
But Bastian has a question. Do you want to? Yeah.
Yeah, sure. I can just say, so the cases where the undergrads would be more expensive, it means that the Mechanical Turk people would be exploited more because they have longer tasks.
Sorry, can you say that again? It was really choppy at the beginning. Sorry.
Oh, sorry, no problem. Let me also close the window to have less of the piano playing people outside. So I said the cases where Mechanical Turk would come off better in terms of the cost. It means you exploit the Mechanical Turk users even more because the tasks are comparatively long and they are paid by the piece. So their hourly income in comparison is just much lower than it would be for the undergrads, as they are paid by the time and not by the piece.
Yeah, so I think so within this, that's within this project, that's true, but it's also sensitive to how large the microtask that they take the piece rate from is, because they're taking the piece rate as just a, 20 cents per classification or something, and then they're multiplying that by the hours, by the number of classifications in this project, not on Mechanical Turk.
So they did not try to adjust for the actual piece size and how much you would pay given the size of. I see. Okay, thanks.
Yeah, and so you could see if you took the piece rate from larger tasks, the graph looks, the directions are the same, but it looks a little bit different. Yeah, but yeah, that's basically right. Okay, so and basically the conclusion here is that okay, yeah, they do contribute a pretty high value of labor. And I don't like to look at this because I get told repeatedly that it costs my lab $50,000 a year to have me. I think a little bit more than that. So when I look at this, it makes me feel like I'm not productive enough. Okay, so they've looked at the value, and now they're going to try to understand like which users. We know that users are contributing value. Now we want to understand which users are contributing how much value. And they're going to use Lorenz curves, which are a way to visualize inequality for each of these 7 projects. The way to interpret this is basically we're looking at the cumulative distributions on the x-axis of the number of contributors and the cumulative distribution on the y-axis of the total number of classifications. So usually the Lorenz curves were originally developed for income inequality. So you'd usually have income on the y-axis and the population on the x. And so the way to interpret this is that perfect equality is that 45-degree line. And as we increase the severity of the bow down, we're increasing inequality. And we can measure that inequality using something called a Gini coefficient, which is basically taking the area between the 45-degree, the area above the curve, but below the 45-degree line, and dividing that by the total area under the 45-degree line. So if it's 0, we are perfectly equal. If it's 1, we're highly skewed. We're really unequal. So the Gini coefficients, there's some heterogeneity between the projects, and it's unclear why. We know where the heterogeneity is coming from, but it's not sure what's causing that. But the range is between about 0.77 to 0.91.
I think, because I've seen, it's funny, it's exactly the same in the context of iGEM that I was talking before. And the way I compute that usually is more saying that 20% of the team or 20% of the contributors contribute to 80% of the work, which is kind of what you have here. You have between 10 and 20% of the people do 80% of the work. Yeah,
well, and that's what they actually note that. And that's pretty common. This is exactly what we'd expect, not just in, we also see this in open source development. Yeah. It's the Gini coefficients are around in the 0.7s. Wikipedia is like 0.92. And scientific research, there's something called the Ortega hypothesis, two Merton students publish a paper that really pissed a lot of people off, basically saying that in science, very few people actually, most of the discoveries are made by the very top of the distribution. And most of the citations are accrued there too. Yeah, so this is not terribly surprising. I also just want to issue an apology to all the network people that this isn't shown linear in the log. I know
Yeah, I was
I know that's upsetting.
I was too. But thanks for apologizing.
Yeah.
Dule asks a question regarding these super contributors. He asks, is this considered a problem, this Gini coefficient? And how do we identify the right users to attract? Do we know how different user types are different? You know, like, do you know that a bit in advance?
Yeah, so you're reading my mind. So like one of the things that I have at the end where I'm trying to thinking about what are some of the interesting questions that we should ask is looking at contribution, intensity, frequency, and quality conditional on all of the features of the user that we can get. So conditional on their skill level, conditional on the type of task that they're being asked to perform, all these things. Sauerman and Franzoni suggest something kind of interesting about the match quality that, you know, it's unclear whether the people that stick around are actually have different motivations, or if they have the same motivations, but they, for some reason early on, had those motivations really reinforced and then kept contributing because they, you know, it'd be like joining a project and having all of the skills and the other characteristics required to be a really meaningful contributor, but just feeling not very welcome until you drop out, versus the exact same person joining that project and everybody being really welcoming, and so they get that sort of satisfaction of working with other people, and now they're going to stay around for longer. I think that's an empirical question that we ought to ask.
Yeah, do you like automatize sentiment analysis to try to get at that? Like, how do you do that? How do you measure that?
I've taken a strong stance in my research to not care about people's feelings because it's very hard to measure. So I don't have a good answer for you. I think that stuff is probably better suited for qualitative work. I've seen sentiment analysis and like NLP methods try to do this, but I think it's not so great. It's good at pulling out what sort of problems are people having, but not so great at pulling out what are people's emotional reactions, because a lot of that won't be captured in a Slack conversation.
I see. So you basically do more like a well-crafted survey / interview, and then you do coding on that, and then you like do the whole classic sociology / psychology methodology of looking at qualitative empirical research on humans. Yeah,
I think if you've got good structured exit interviews, that's probably the best fit for that. In terms of the quality, because there's not necessarily we don't necessarily need that many observations for that kind of stuff.
I'm also wondering, I mean, even without interviews, people here, they have data, they have longitudinal data about the people's contribution. So typically I would expect that people contributing more, maybe they're long-time contributors. They just come here and they have this routine. And I was wondering if there was such a thing here as kind of like people that they have been there for a long time, they are veterans, right? Versus newbie, and how that can play in explaining maybe a simple model of that distribution.
Yeah, I mean, I think being able to differentiate between the individual level characteristics of users is going to be really important. And certainly if we can see that somebody is bouncing around between projects, but stays within, I mean, if we can get that group and then get another group of people that basically walks into Jogo and then leaves and never contributes to GitHub or never contributes to Zooniverse or whatever again, that'd be awesome. One of the ways to do that would be to ask people up, and then also ask go to Zooniverse and ask if they have user logs, if they have user emails, and then do some matching there and see if people are serial sort of open source or crowd science contributors, or if they're being attracted by the content. And there's some, that can be really important for quality as well. One of my colleagues here at Tech has, in his job market paper, one of the papers in his dissertation, which I think he uses his job market paper, he's looking at ecological, like sort of environmental protection organizations. And he's got a bunch of direct observation data on people working in frog, I think it's frog, like wetlands conservation, turtles and frogs and stuff. And they find that the people who are really motivated by the content, like if you work in this because you really love turtles, you make really bad decisions. Where if you come in and if you come in for other motivations, like you just, you don't have anything else to do in your free time, you tend to make the sort of decisions that you would want for the long-term viability of the ecosystem. And I think we could see something like that here as well. That, if you're too close to the action, if you join because you're really motivated by the problem, we could see different types of behavior in terms of quality. And maybe in survival as well. Okay, I'll move on. So you sort of brought up this slide a second ago. Here they're looking at how contribution evolves over the project timeline. So like how many hours a day are contributed across the lifespan of the project by people's sort of entry time. So the red is people who joined in a moving 7-day window. So if I look at the age of the project in 30 days, then the red line is showing everybody who joined between day 23 and day 30. Gray is everybody who joined sort of in the span between whatever time I'm at now and after day 7, and then the blue people are the people who joined right at the start. And this sort of suggests a couple of things. The first is that the contributions are infrequent and they're relatively low intensity. Second is that only 17 to 40% of users contribute more than once. The other way to say this is that 80% of the contribution is done by 20% of the people, which they actually say in the paper. So Mark gets a sticker for that. And then the mean daily contribution across all days is really low. So we're looking at like 7 to 26 minutes. I think a lot of it has to do with the type of tasks that people are being asked to do. That this is equivalent to playing a game on your phone. One of those really addictive games on your phone where I can come in and play a couple rounds and then leave. Where for more complex tasks, that's not really possible.
I mean, it makes it look negative, but honestly, having a sustained activity for 6 months that is still flat, I consider that more like a success. It's pretty impressive to sustain activity on that. It's basically constant after day 60. It's basically constant, right? Which means
No, sorry, go ahead.
I mean, I mean, just seeing the curve, say the open COVID-19 community. Yeah, I mean, you also end up having a constant chat, but it's only 3 months. I don't know. It feels like this is kind of the growl of these open science communities. It's kind of like having that sustained thing last and last and last, right? And I guess at some point you end up having the core of contributors.
I mean, I think there's so the other thing is you see these spikes. And these spikes are driven by they interviewed people on the projects as well. And these spikes are basically driven by things showing up in the news or basically anything else where you get a spike in publicity. So there's some ability to recruit that way. But I think to what you're saying, Mark, it's a lot of times we think about size as a is linear and as a good thing. Like size being always good for a project. In many cases, that's not true, particularly the more ill-structured we get. When we increase size, coordination costs really increase. And as we increase size, we also tend to be more conventional and less novel. And so it could be the case. I mean, it depends on whether we're losing people who would otherwise have been really productive contributors. But if that's not happening, then another way to read this is that we're getting a really efficient allocation of people in and out of the project within the first month or so. That the people join, the people who aren't gonna be major contributors, but are gonna take up a lot of resources, leave, and then we reach a more efficient equilibria.
Yeah, and building on a few questions that are asked on the chat. Well, first, I'm not sure which project this is. This
is aggregate.
This is aggregate. So because the question is, did they try to relate various projects and various behaviors to various outcomes? And in which case, did they specify an outcome that was desired or a success that was desired? And second thing is, and that's from Luba, that there are some pikes in that data, and it looks like what Thomas Maillard was presenting about the exogenous shocks that can bring some activity. So it was just a comment on that. But did they a bit compare different projects and different behaviors, or it's just they looked at the aggregated thing?
So they break this out in the supplemental.
Okay.
I can't remember exactly what it looks at, but they're also measuring at this whole paper, both of these papers are measuring performance at the level of the task and not at the level of the project. So we don't have a good sense of whether these projects were successful, but we do have a sense that, and all we get in terms of quality on the task is that it met at least some threshold. They crossed some threshold of acceptability, but we don't have, one of the things, there's a lot of great things about their data here. One of the things I don't like is that we don't have a good way to differentiate quality or the project success as a whole.
No, but you could say project success is about having had a lot of productivity per capita, right? That would be the engagement over the project. Or
I think we have to be really careful in defining exactly what success is. Yeah, because it depends on the structure of the problem we're trying to solve. For some problems that we're trying to solve, productivity doesn't really help us that much. And it might take a really long time to solve one task, or we might have a lot of tasks that fail. And that's fine, that's not a problem. We're just trying to narrow the search space. So I think it really, I mean, just generally, we want to be really careful about what project success is. It could be productivity. It could be, for open COVID, it could be, how many deaths from, how can we minimize deaths from COVID-19? And then we have a lot of conflicting, we have a lot of conflicting values, like trying to maximize inclusion and participation. When, oftentimes we want a smaller team, we're going to have a conflict between those two. We just need to really clearly define which one, just like you do if you're modeling. Everything in the world is constrained optimization. Okay, I'll move on. So this is expanding, just going a little bit deeper into these things. I think on the left is showing the sort of share of contributors across each of these. This is split out by project now. So this is the share of contributors across the 7 different projects that fall into one of 4 categories. And they're categorizing by whether they are single day contributors or they contribute multiple days, not necessarily in a row, but just they contribute more than once. And by the intensity. So they're taking the, if you're below the 90th percentile, they say you're a short average time user. If 90th percentile, they call you a long average time user. And so they've got the share of those groups in, on the left side. On the right side, they're looking at the share of classification, so their productivity. And this makes it really makes a couple of things really clear. First is that multiple days far outcompete single days, which is pretty obvious. And the second is that intensities looks to be important, but it's not that important.
No.
And it really varies, intensity varies by project, right? So the long average time users are remarkably stable. If you look across project A, it's about 7 to 4%, pretty low variance. Where when you look at the short time users, much higher variance. And the short time users are also a larger group. Which I mean, I think really supports that observation.
I mean, it seems like the long-term users, maybe they are heavily shared between those different projects. Maybe they represent a core on Galaxy Zoo of active contributors, right? And that's why they have low variance.
Yeah, I don't know if I don't think they looked at this. I don't think they looked at that. But I want to email Henry about something else. I might ask him. By the way, he just a week ago, 2 weeks ago, a week ago, I saw him present experimental work on people in crowd science generating. So somebody said earlier, I think it was Bastian, was talking about, are they coming up with the subtasks themselves, or are they not? And Henry just did an experiment looking at the quality of research questions generated by crowd science, by sort of like users versus professional scientists. So they're looking at like physicians, patients, and like master's trained public health people, I think. And it's probably the best first draft of a paper I've ever seen. It's really depressing. Okay. So that's basically the core of the second paper. Both papers pretty simple, heavily descriptive. And they, in both of these papers, they raise a common set of organizational challenges. So the first is it's difficult to match projects and people. There's a lot of questions about leadership. I'm not familiar with the leadership literature, but there's a really important question we have to ask within Jogo or within Open COVID, which is, do you want subject experts? Do you want content matter experts to be leading a project? Like if we have a project on network science, does Mark lead it, or does somebody who's an expert in how the organization needs to run manage that project? And it's not clear which is the right way to go. And I think we have some heterogeneity within Jogo. So maybe we can exploit that and look at that. I think we ought to ask questions about that in the long term. So like when you move from Open COVID to the next one, to the next one, to the next one, can we effectively recruit more subject matter experts? Or is it more efficient to have people floating between subjects? The sustaining contributor involvement thing is a pretty obvious problem. I think this is really about it's really about differentiating between people's rewards and then reinforcing those rewards through the project. They raise this idea of trying to support broader sort of pecuniary motivations. So like, there's not that many firms involved in this sort of stuff. And part of that is because it's difficult to appropriate any knowledge or technology that you develop because all of the intermediate inputs and the final outputs are shared. So if I can't exclude other firms from capturing something that I fund, my motivation to spend money on that is really low. Because I'm basically underwriting the R&D of other companies. So I'm a little bit, both I and the authors are a little bit hazy on whether that's necessary. And then we have these problems of conflicting conflicting motivations. So the ability to recruit professional scientists is relatively low because all of the intermediate inputs are shared. So for someone like me, the meta study stuff is relatively closed off, and the intermediate inputs are relatively exclusive compared to a lot of the other things in Jogo.
Mhm.
And so I still have some expectation of being able to publish things, but if I mean, one of the things you can notice just anecdotally in watching the there's a couple of professional labs, like large academic labs that are on Jogo. And if you just take a really quick look at what they share versus what the other projects share, it's much more guarded. They don't share nearly as much. And I think it's basically for these sort of conflicting motivation reasons they're talking about. Okay, so now for oh, hey, I'm almost on time. So I think there's a couple high level suggestions. We can get really deep into this. But a couple high level things I think we ought to look at. The first is we should look at user behavior like they look at in their papers, conditional on the skill and task features of the project, the sort of organizational structure, the bureaucratization, coordination, which is the way that you're organizing organization, communication, and work within the team, kind of technologies they're using, and the user characteristics. I think you should do the same thing for project performance and throw user behavior and match quality in there as well, because two-stage least squares is cool. And we should look at the user project match quality as well. It's important to note for the last two are really difficult to design. So we need to think really carefully about how to measure these and build performance tracking into Jogo for all of these. Yeah, so that's the first one. The second is that we're gonna have a lot of problems with sampling bias, because even though we have sort of Jogo or the Slack or whatever as kind of essentially organizing feature, the actual work isn't conducted within Jogo or Slack. It's distributed across a whole lot of different media. And that's gonna contribute, it's gonna make it really difficult to figure out where we're over and underestimating. So I think surveys are a decent way to do that. And then the optimization thing at the end too. So when we're measuring project performance, we need to measure success at the task level, we need to measure good performance at the task level. We want to measure what's good performance at the project level, and then we need a really good sense of what our constraints are. So how should we value these performances so that when we go in and apply interventions, we're not doing it because we want to design an intervention, and we have a really clear sense of exactly how much am I willing to trade off, like say inclusion for efficiency, or exactly how much am I willing to trade off resources for publicity, all these sorts of things. I think that's my last. Yeah. So if there's any more questions or if anything anybody wants to talk about.
Yeah. Well, first, thanks a lot for it. It was very, very interesting and very useful and very orthogonal to the previous talks. So it's very, very good. I do have still some remarks, maybe, and if anyone else also wants to speak.
Yeah.
You want to go for it?
Yeah, actually, it was indeed orthogonal in the sense that, for example, the figure 4, which you showed, that was some dimensions which were orthogonal to ones which were presenting from this book on the augmented collective intelligence, right? Because there, if you remember the schema, there was an axis. So if it is X and Y, there was an Z axis for computer interactions. And actually there, Wikipedia also was posted somewhere in the between those two. I don't know if you looked into that book. It was a bit your talk was much more like in depth kind of yeah, but thanks a lot.
Yes, if like I wouldn't compare it to that book, to be honest. Like that book was a bit too disappointing.
Yeah, it was not in the analysis side.
Yeah, exactly.
More
Like
descriptions.
no, because
on
it was
purpose.
disappointing the way like what I expected it to be. But to be honest, like what from your first slide, the organized skepticism just like that just caught my attention, and I'm just still thinking about it.
Yeah, I mean, there's a lot of particularly French people who disagree with Merton. Bourdieu and Latour both have some gripes about this, more on the norms, but the organized skepticism is pretty constant. Same with
I like
communism.
it.
It's
I'm gonna
universalism and disinterestedness is what people disagree with. The French spent too much time around postmodernists. And
actually, no, but that's a very important thing, that it seems to me, maybe I'm wrong, but it seems to me there is not in this platform or in this crowd science things, the aspect of peer reviewing, or I don't know if it is there. I maybe I'm not knowledgeable enough, but for me, that's like, how do you ask, you know, in things that are a bit more complex than classification, how do you assess quality? Because you can assess it with redundancy and having two people do the same thing twice. But you know, do you have at some point this kind of peer review system of a task or quality assessment?
yeah, I think one of that's a really important structural feature. That, I mean, so there's two things. The first is that the speed at which many of these projects progress is not compatible with the sort of precaution that most scientists would take in the lab. And the second is that not only do many of the people don't have the skill to evaluate good work, or the expertise to evaluate good work. So it's actually pretty easy for me to take somebody and put them in this is, you know, just a biology example. It's really easy for me to put somebody in a lab and teach them how to pipette and do all of the technical tasks, and they still won't understand what a good purification actually is, or how to interpret this result or that result. So I think Sauerman and Franzoni sort of mentioned this, that it's you want to have this sort of checked, not necessarily a peer review, but there's some organizational feature that by which when a task is completed, it is still reviewed. I think they suggest, you know, by a professional scientist, but their professional scientists are expensive and already have a bunch of other stuff.
I would say that too. Like I just recalled of this project that Samir Brahmachari and their team in India are doing called open source drug discovery, and like that was the one where I thought, hey, this is not a classification task. Like you have to validate the results. So I went to the website to check it out, and it looks like, so basically the students did some work, and the scientists were then supposed to like work upon the work to like sort of ensure the validity of the scientific work. But yeah, I think it was sort of like that.
Yeah, what they did was a bit in between iGEM and professional lab. It was kind of like much more open science, highly complex teams with some outsourcing to students, but I think it was more like similar to what it could have been a program on Juggle, and they had kind of a tools to work in the open. And the thing is that it was a high coordination cost, and Anshu was spending 24/7 calling different labs, coordinating, etc. That's a very high coordination cost, because you know that the things that at some points you know, like if this gets complex, if you don't have a good system of cross peer review and motivational engagement and personal incentives and citation that you build your career on, it's harder to retain.
I do not actually have any links. Like I just Googled open source drug discovery.
Yeah, OSDD it would be the link, the last one.
Yeah, like I just found that because, but yeah, like this, it was an it's still an interesting question though. Like, what's in between though? What's in between like pure hard science and classification problems, triviality?
The advantage of the classification problems is that if I can trust my sampling, if I have good representative sampling, then I can figure out whether people are making good classifications or not statistically.
Which, sorry, just last thing to remark, which reminds me of another thing about Mechanical Turk, that for some, I recall that for some surveys or something, they like actually have like a very good selection process of people based on like demographic choices, or like if you have gone to school or something to do surveys. But it just made me feel like, isn't that like biasing the like survey in itself by like picking the people with specific things?
You want to, I going to a professional survey, I haven't worked with Mechanical Turk, but these professional survey companies do a really good job of, if you want a sample that's representative of, you know, X, Y, or Z, they will get you a sample that's representative of X, Y, or Z. And you want the representative sample. I don't want to go out blindly and choose people, because you can't get it randomly. So I think they're sort of removing bias from the sample by giving you a really clear estimation. They're minimizing bias in your sampling by giving you a really clear understanding of exactly what you're getting. And if you can, and you want to specify in advance, like if I'm asking people about, if I'm going to give people a bunch of vignettes about what would you do if you were a manager in this situation, and in addition to demographic stuff, I want to make sure that I'm randomized across work experience.
Right.
And so you basically give them a list of all these things, and they go out and find those people for you. It's like magic.
That's good to know. Like, wow.
What's worse is we just saw a paper that had a 1.2% response rate, and probably the worst sampling I've ever seen in my life. And so they're asking about gender in academia, and everybody they emailed was, almost everybody was a woman, and only 1.2% of them responded. Right. So that's what happens when you go out on your own. That's what you don't want.
Amazing.
Thanks for the talk, though. I need to go too, and I guess we are wrapping up.
Yeah. We can wrap up. I just wanted to tell you, Robbie, we had a discussion before in the recommendation system meeting with Pedro and others. We're gonna make an outline next week of what's a good way to describe the open COVID-19, like to release the data set in the open on like the Juggle and Slack data set, and maybe build some descriptive models on looking at what created activity, maybe in relation to outcomes such as how sustained the project, a self-organizing project was, like put clear what are all the data, and maybe try to put together a simple model so that we could simulate, you know, how to grow an open science project, what are the main parameters, so that then we can have this little paper about the data, describing it, that would be the basis for then deploying the recommender system and kind of actually testing it and experimenting it. So we're going to do that next week, and we'll share with you. I think it's not going to be on US times, but we can have a discussion afterwards related to your open question at the end, so that we're sure that we're aligned in this paper with respect to this question, and then we can easily do some tasks, data science tasks, etc.
Yeah, awesome. Yeah, I think there's a lot of hazard model questions here. There are a lot of good survival model questions.
Exactly. So that's exactly what we need to get. And so next week, we have at that time a discussion with a community of students that want to do visualization, and Pauline presented us to them. It's called the CVC, Coronavirus Community, or Coronavirus Visualization Community. And we're going to discuss how they could help maybe do some visualization for us and with the meta science project. So that's one thing. And I was proposing that the week after, I will contact an organization called SciStarter. They're specialized in doing citizen science projects, and they're a platform for doing citizen science projects. And they have implemented the recommender system last year, and they have tested it against several classic recommender systems. And they did that under a Nesta grant. And so I wanted to propose them to come and give a talk about their experience trying that out in that like system that is very close to what you have actually shown us today. And I think it would be a good way to get some feedback about their own experience with it. So that's for the next times.
And also thanks for a lot of keywords that I like picked up from your from your presentation, because I did not have any idea what they mean, and I still don't, but at least I have written it down now.
I'm just here to say no and to give you words and papers from 40 years ago. It's my primary crutch. That's all I do all day. Well, and a lot of coding, but it's like reading papers from the 30s and then coding and then going back and forth.
Hey kid, do you want some keywords, huh?
Hey, it's only got 15 sites, kid. Come on. You get your disruption scores up.
Well, it was good to see you all and to have also some more people coming. So thank you for joining. Thanks everyone, and see you next week.
Thanks everyone.